The last example from exercise 4C. Now, I think we have 2, 3 more questions. Okay, then after that, we'll talk about something different. Not different, but we will actually consider these cases in a more depth, okay? The equation of a straight line and the midpoint of a line segment. And after that, we will see some different problems involving these concepts. Okay, that's just a few questions for warm up. This is another example from exercise 4.3. Okay, that is question 9. A straight line passes through the points A and B. Okay, write down its gradient. All right, write down its equation. So we know what are the things. And question B is the line x equals 3 is the axis of symmetry of A, B, C. Find the coordinates of C. But to do this one, I think we need to draw this. That's why actually I put here these two lines so that we can actually draw a more accurate picture of this thing. So if you start with A, write down its gradient. So immediately using this M gradient of these 2 points, actually, what we mean by gradient of AB, we're talking about the gradient of a line, right? That's passing through these 2 points. That's equal to 12 minus 3. That is 9 over 3 minus 0. That's equal to 3. So the gradient of this line is 3. And how about the equation? Since I know this, right, on the left-hand side, I can just write here y minus y1. Take this one as a first point, y minus 3 over x minus 0. On the right-hand side, we have the gradient. So the equation of this line is y is equal to 3x plus 3, right? That's the equation. So how about B? It says that the line x equals 3 is the axis of symmetry of triangle ABC. So what is A? A is somewhere here, 0, 1, 2, 3. Okay, this one is point A, the location of A. And B is 3, 12. That is, let's say 1, 2, 3. And the 12 is, let's say, somewhere here. Okay, that is point B, whose coordinates are 3 and 12. And x equals 3, that one is 1, 2, 3. X equals 3 is the axis of symmetry ABC. So if I just draw the line, we are talking about this line. It must be a straight line, actually. That's the line of the symmetry. So it says find the coordinates of C. So if I just join this A and B, we will get one side of this triangle, right? And where can C be first? Is it somewhere here? Is it somewhere here? So since this is a line of symmetry, the other half of this triangle must be somewhere here, right? So since it's a line of symmetry, if I draw a line, right, through here, so C is somewhere here, actually. They are that A and C, they must be equidistant from this line, or particularly from this point. So the distance between this point and this point, that is 3. So I need to move 3 units to the right. So here we have 4, 5, 6. So that is the location of C. Then what's the location of C? It's from 3, right? 4, 5, 6. So this point is 3. And 6, this point is 3. So the coordinates of C must be then 6, 3. So it is somewhere here. So if you just join this, we will get the triangle ABC.
Okay.
Good. Very easy question. Another question that appears actually in this concept in most books. Find the values of k if the lines, we are given 2 lines, that's the equation of the first line, that's the equation of the second line, have the same gradients. Okay. To answer this question, first we need to actually write both equations in gradient form. By gradient form, we mean that we have to convert this into this form, mx plus c, right? So just doing some simple algebraic manipulation, the first one we will get y is equal to 2 over k. X, just divide both sides by k, minus 5 over k. And how about the second equation? Take this 3 to the left and divide by 6. So we will have y is equal to k plus 1 over 6, right? All right, plus 3 over 6, that's equal to 1 over 2. And here we have x. So actually, we just wrote both equations in this form. That's a gradient form. Actually, gradient intercept, as sometimes we just call this gradient form, because if you consider this m and also c, that is y-intercept. This one is the gradient. Anyway, so since we are saying in the question, it says that they have the same gradients, right? What is the gradient of the first line? That is 2 over k. Gradient of the second line, that is k plus 1 over 6. So from here, since gradients are equal, these two things must be equal to each other. Now from here, if you just cross multiply, we will get k squared plus k. On the left hand side, we have 2 times 6, that's 12. Take the right hand side. So we will have here 12, not 16. So here we have 12. It's just a quadratic equation. We know how to solve this. You can just solve this by factorization, right? That is 4 times -3, 4 plus -3, so it works. K plus 4 and k minus 12, that's equal to 0. So it says that find the values of k. So it has two possible values. The first one is k equals -4, or k is equal to 12. So when we just substitute these values, then these two lines will be parallel to each other. Maybe imagine this k equals -4, we have something like this, line 1 and line 2. When k equals 12, maybe we got different lines, but we're sure that for both values, these lines, graphs of these equations will be parallel to each other. Okay, Shahina, Amira?
Mm-hmm.
Good. Question 14, is it the last question? Oh, we have one more question. So the last question, you will solve it. P is a point 2, 3, and Q is a point 9, 5. All right, find the equation of the line joining PQ. Do we have space here? Good. So, okay, we can answer the question later. Question A, find the equation of the line joining PQ. What is it? Y minus y1. Let's say this one is the first point, that's the second point. So it is 3 over x minus 2 equals, and here we have just the gradient of this line, that is 5 minus 3, that's equal to 2, over 9 minus 2, that's equal to 7. Or from here, if you just cross multiply, 7y minus 21 equals 2x minus 4. Or 2x minus 7y plus 17 is equal to 0. I don't know in what form we should leave this. That's a general form. Or gradient form is, what is it? 2 over 7x plus 17 over 7. They mean the same thing. Okay, that is the answer to the first question. Find the equation of the line joining PQ. How about question B? Find the coordinates of the point where the line PQ intersects the x-axis. So where the PQ, the line PQ intersects the x-axis. How do you find that means the intersect x-axis means they're asking the x-intercept, right?
Mm-hmm.
X-intercept. To find the x-intercept, we know that y should be equal to 0, right?
Yeah.
So if y equals 0, substitute here. So this will be 2x plus 0, actually minus 0, plus 17 is equal to 0. Now from here, x equals negative 17 over 2. So the line crosses the x-axis at this point. Okay, now we can draw this maybe. So the line y equals 5 is the line of symmetry of PQR. Find the coordinates of R. Okay, now if I just draw the picture, it does it look like 2, 3, and 9, 5. So here we have, okay. That is y-axis, this one is x-axis. Point P is 2, 3. 2, 3 is, let's say it is somewhere here, that is point P. And the Q is 9, 5. Explain it just right because we will need this. 2, 3. And the Q is 9, 5. 9, 5 is somewhere here. So let's say here, Q. that is x coordinate is 9 and y coordinate is 5. Okay, that's PQ. And find the coordinates of the point where the line PQ intersects the x-axis. Wrote it down. Is y equals 5 is the line of symmetry PQR. Find the coordinates of R. So y equals 5. What is y equals 5? Y equals 5 is this equation, right? This line. Okay, let me just click here. That is the graph of the equation y equals 5. And it says that that is the line of symmetry of PQR. So that is P and Q. If I just join this, here we have PQ. And where must be R? So it must be somewhere here, right? So here, the distance from here, this 3, right? Here we have 4 and 5. It is 2 units away from point P. And also, the R must be 2 units away from this, from the line of symmetry. So if it is here, is 1 and 2 somewhere here. So that is the location of point R. All right. So that is R. So what are the coordinates of R? X coordinate, it must be 2. How about Y coordinate? From here, 4 units to 2, that is 7. Right? Actually, with ruler, you can draw more accurately. That is the location of R. Okay. That is, all right, done. This one, location of, okay, find the coordinates of R. Calculate the area of PQR. Okay, now we need to calculate the area of PQR. That is P, this one is P, right? And this one is Q, this one is R. How do we calculate the area of PQR?
Base times height divided by 2, so the length of PR times
the length of PR. What is the length of
yeah.
PR? Four, right?
Yeah,
because from here to
7 minus
2,
3.
it is 2, that's 4 times.
So it's 4.
How about the height?
The height would be what are the coordinates of Q again?
9, 5.
Oh, 9. Oh, okay. The height would be 7.
7, because it is parallel to the x-axis, so it is from 2 to 9, that is 7.
Yeah.
That's good. So that's equal to 14 squares units or square units. Okay, this is done. Now E, calculate the length of PQ and hence calculate the perpendicular distance from R to the line PQ. Okay, first we need to find PQ. And what is PQ? PQ is here. And we know the coordinates of P and Q. So E, PQ is equal to the square root of the square of the difference of x-axis. That is 9 minus 2. So that is 9 minus 2 squared plus square of difference of actually y-axis. That is 5 minus 3. So here we have 5 minus 3 squared, which is equal to, here we have 7 squared, that's 49, plus 2 squared, that is 4, which is equal to square root of 53. And now in the question it says that, what is this? And hence, that means using your result, calculate the perpendicular distance from R to PQ. So from R to PQ. From R, where's R? Here, PQ is here. So let's say perpendicular will be somewhere here, right? And let's say that's equal to H. And I think you have some idea how to do that, right? How do you find H?
Not too sure.
Last time we saw a similar question, you remember?
Yeah. I remember that, but I can't remember how you did it. The solution that I'm thinking of is it was wrong last time as well. So
Here we know the area PQR, right? And as you know, in
yes.
very different ways, actually, we can calculate the area of the triangle. That is
Mm-hmm.
one way. So we know the area of triangle PQR. And let's just find this using different way. Use, how about this altitude, this height to this base. So we can just find it as 1 over 2
Oh
times
yeah. Okay.
PQ times H. And we know the area, it is
Mm-hmm.
14. And also PQ, we have just found here. So from
Yes.
here, then H must be equal to, multiply both sides by 2, 28 over divided by PQ. That is square root of 53. That's the exact length of the height from R to the side PQ. And the question, they
Okay.
say that leave your answer correct to maybe 3 significant figures or correct to 2 decimal places. Accordingly, we can just write the leave our answer. 120, 120 figure. Thank you. Aslında bir iş yerinde badminton gitmemiz oldu. 535. Amira, that's the last question. Okay, we will read it together. We will solve
Mm-hmm.
this together. But the last question, I will leave it for you. Maybe question C, I don't know. We will see. Okay, let's just start it together. And one question here, I don't know, maybe question C or question D, a little bit challenging. So you will try the question. Can you read the problem?
In the diagram, ABCD is a trapezium with AB parallel to DC. Given that CD is equal to 9 units, B is the point 11,6, C is the point T0, D is the point -20, and the area of the trapezium is 84 units squared. Find A, the value of T, B, the length of BC, C, the coordinates of A, D, the equation of AD.
Okay. Most of the time, I don't know myself, even though I'm teaching math for a long time, the first reading, I don't understand much. I may have some idea, but I have to read it again, then I understand. So in the diagram anyway, here we have a diagram and it's given a trapezium, right? A, B, C, D. And the coordinates of some vertices, it's given. Here B, we know that. C, we don't know, on X coordinate. D also is given. All right. So AB is parallel to DC. All right, with this side is parallel to to this side. Given that CD equals 9, where is CD? CD is here. So CD equals 9. Okay, good. So question A. Let me use what color here? Maybe blue. All right, question A. Find the value of T. How do you find the value of T?
You add 9 to -2 to get 7.
This CD is given, right? It is on the x-axis. So just the distance, that is T minus 2, that should be equal to the length of CD, which is equal to 9. So from here, T is equal to, what is it? 7. Therefore, coordinates of C, what is it? It is 7, 0. Done. B, the length of BC. So since I know the coordinates of C and we know the coordinates of B, so we can find its length. BC is equal to square root of 11 minus T. T equals 7. That is 11 minus 7 squared plus the square of the difference of y coordinates. That is 6 minus 0 squared. Actually, I mean, I know you can calculate this. Okay, but as I told you, we need to just show our work. That's why I'm writing everything here. So you have to get used to it. Maybe if you're going to sit for the exam. Anyway, here we have 11 minus 7 is 4 squared. That is 16 plus 36, which is equal to square root of 52. Or 4 times 13, 2 times square root of 13. Right? Good. So Amira, next question is for you. Okay. The coordinates of A. So I will give you 3 minutes. You try it. If you solve, it's good. Otherwise, we will discuss together after 3 minutes. You can just do it in a
Okay.
paper. All right, time starts now. Okay. Did you get anything, Amira? Hello?
Yeah, hello? I'm just putting it into the calculator.
Okay. But do you need a calculator for this?
I think I do.
I don't think so.
Oh, well, it's probably wrong then.
Okay, use a calculator. Just let me see what's your result.
Hmm.
What did you get?
I got, -9. -9 and 6.
-9 and 6. Okay. So can you tell me your methods? How did you find it?
I don't know if this was the right one, but I assumed that the length of AD was the same as BC.
No, it's not given.
Yeah, because it doesn't say that they're like equal, but I didn't know what else to do.
Yeah, that's why you cannot use this. You cannot take it as a fact because it's not given.
Yeah, exactly.
-9, 6, I don't know, but okay, but still, if you assume that they are equal, then what did you do next?
I just worked backwards to work out the x coordinate of A.
Okay. Just minutes. I need this. Okay. Okay, question C, the coordinates of A. What we know so far, we know the coordinates of C. That is 7, 0. Okay, this one is 7, 0. And what else is given here? I'm going to use this method. What is given here? The area of the trapezium is 84. So here, let me just use green. So area of the trapezium A, B, C, D is equal to 84. Now, because we know that this side is parallel to this side, right? That means that y coordinate of any point on this line, it must be the same, right? It must be constant, it doesn't change, it's all 6. So here, what is the x coordinate of A? I don't know. We are trying to find this. And how about the y coordinate? It is 6, right? So now, how do you find the area of the trapezium? And we know that the area of the trapezium is half the sum of the parallel sides, right? That is AB. This is the first parallel side. The second one is plus CD over 2 times height. That's equal to 84. So do we know the height? Height is the distance between the parallel sides, right? The distance from here until here. And what is it? The distance is, what is it? 11. No, 6.
Yeah, 11.
11 or 6? 6.
I think.
6. Because 6, right? This point is 6.
Yeah, because 11's x.
Yeah, it's 6. So here we have 84 equals, here we have 6. 6 over 2 times. And what is AB? So AB is, it is parallel to the x-axis, right? That's why we should just find the difference between their x coordinates. So that's equal to 11 minus x. The length of AB is 11 minus x. Plus, how about CD? CD we have already calculated, right? That is 7 minus minus 2. That's equal to 9. And that's it. Now we can find x from here. It is equal to 6 over 2 is 3. 11 plus 9 is 20 minus x equals 84 over 3. From here, x equals 20 minus 84 over 3. What is it? 28, right? Or 27?
Yes.
28, I think. Yes, 28, which is equal to minus 8. So the coordinates of A are negative 8 and 6.
Okay.
Okay. And
I
this
get the
also,
method.
it's also interesting. Why did I ask Amira? You may wonder, because when I asked this question, especially this question, here we have 4 questions. Most of the students, like 70% of the students in the class, they cannot solve it. That's why I just wondered, you belong to the 70% or 30%? Just kidding. Okay. It's fine. Maybe if I give you more time, you can think and try this. Okay. But what you learn from here is, Amira, if the information is not given, you should not take it as a fact. That most students make this mistake. Because in coordinate geometry, in the questions, most of the time, the figures are not drawn to scale. It may look actually equal, but they are not equal. Unless it's given in the question. So the last part of the question is the equation of AD. And we know the coordinates of A and D. Now we can write, actually, that is not 9. So that is 8. Okay. So now we can write, that is part C, and the D, equation of AD. And what is the equation of AD? That's just equal to y minus 6 over x minus 8, that is plus 8, is equal to 6 minus 0, that is 6, over minus 8 minus 2, that is minus 6. Now from here, y minus 6 equals negative 1, so negative 8 minus 8. So the equation of the line AD is y is equal to negative x minus 2. That is the equation of that line. Okay?
Mhm.
Yeah, Amir, now this part is finished. Let's have some break, okay? Our next session will be a bit longer, all right, because now only 36, because I don't want to just start and stop, okay? So you have break like 9 minutes. After 8
Okay.
minutes, I'll send you a link, okay?
Okay.
Okay, see you soon.